In just 5 minutes, let's leverage the Elusiv SDK to send a private transaction on Solana. So especially over the last few months, privacy has been growing continually more important to the Web3 community. And for good reason. Undoubtedly, there are a variety of use cases, both from the user and developer perspective, that can benefit significantly from on-chain privacy. So as a result, we've seen a large number of projects focused on enabling privacy pop up over the past few months. And while even within the Solana ecosystem, there are a few ways to do this, I want to highlight Elusiv. Elusiv is essentially a privacy protocol on Solana that, in simple terms, enables full on-chain privacy in just a few lines of code. Which brings us to this episode of Byte-Size BUIDLing. In just 5 minutes, we'll be using the Elusiv SDK to send an encrypted transaction in 40 lines of code. Alright, so let's jump right into it. First of all, huge shout out to the Elusiv team for this code snippet. All of the code that I'm writing here was adapted directly from the examples that they gave on their documentation. They did a great job with this SDK, so credit is due. So to quickly provide a brief outline before we dive into it, we'll be aiming for about 40 lines of code. We'll start by importing a variety of base libraries. We'll then import one account via private key and create a second fresh account. After that, we'll generate an input seed. Then we'll build and push a transaction to top up our private balance with Elusiv. And finally, we'll build and send our private transaction. So let's get started by importing a few base libraries. To start, we'll need base58. We'll be using this to decode the private key that we use in the account import. Next, we'll need to import a few things for our seed generation. We'll now need this library from the Noble family. This is essentially a cryptographic library that we'll be using for the seed generation. Also from Noble, we'll need to import SHA-512. And then finally, to avoid a common error, we'll need to define the SHA-512 sync attribute. But don't worry, I'll have the Elusiv documentation linked below, so you can head down there and copy the statement directly from their docs and paste it into your script. Additionally, we'll need to import a few different things from Solana Web3.js. We'll need to import connection, key pair, and lamb ports per sol. We can import the Elusiv SDK itself as well. From the Elusiv SDK, we'll import Elusiv as well as seed _ message. Alright, so now that we have all of our base libraries imported, we'll need to go ahead and define both of our accounts. The first account will execute the transactions themselves, and the second account will be the recipient of the transaction. So to start, we'll need to define a variable called private key, and we can set that equal to new uint8 array, then base58.decode, and then the environment variable that you define for your private key. From here, we can also define a variable called account, and that will be set equal to keyPair.fromSecretKey, and then pass in our private key variable that we defined above. And additionally, we'll need to define our recipient. We can simply do keyPair.generate.publicKey. Okay, so now with all of our libraries imported and both of our accounts defined, we can move on to building and pushing the two transactions. To start this process, we'll need to define the input seed. In a moment, we'll be using this input seed in the constructor of our Elusiv instance. We can name this seed, and then we'll be calling the cryptographic library ed that we defined earlier. So we'll do ed.sign, and then in here we can do buffer.from, and then seed message, and UTF-8. Additionally, we'll need to pass in our private key. So we can do account.secretKey, and then we'll need to pass in only the first 32 characters of this private key. So we can just call the slice function and do 032. And now with our input seed defined, we can go ahead and create the Elusiv instance. We can call this Elusiv and set it equal to await elusiv.get Elusiv instance. And then in here, we can go ahead and pass in seed, and then our account.public key. We'll also need to define a connection here. So we can do new connection. Of course, connection is imported directly from Solana Web3.js, which means that directly within connection, we can just go ahead and pass in a Solana RPC node. So let's go ahead and create a Solana node on Chainstack to use in our connection instance here. I've gone ahead and logged into the Chainstack console, so I'll head into my test4 project here. Then I'll go ahead and start the join network process. I'll choose Solana and Solana DevNet, then next. And here, I'll leave this all as default and then deploy it in Ashburn on Chainstack Cloud. And finally, I'll click join network. All right, now we can open the node here and scroll down and then copy the HTTPS endpoint here. Then paste that into our connection instance. Additionally here, we'll need to define the cluster. In this case, it'll be DevNet. All right, so now with our Elusiv instance defined, we can move on to creating our top-up transaction. Within Elusiv, essentially, you need to first top up your Elusiv private balance before making a transaction. So for example, if I want to send 1 sol, I would first need to add at least 1 or more sol to my private balance. In this case, we'll be sending about 0.01 sol, so I'll be topping up my private balance with 0.02 sol. Okay, so we can start by defining our top-up transaction data. We can just name this top-up tx, and then set that equal to await elusiv.build top-up tx, and then in here we can do 0.02, and then multiply that by the lamb ports per sol constant. And then of course, because we're defining this in lamb ports, we can just pass in lamb ports as our second parameter. All right, so now we'll need to sign the top-up transaction. So we can sign it by doing top-up tx.tx, and then partial sign. And then of course we can pass in our account, which contains our private key. And finally, we can go ahead and push the top-up transaction. We can do this in a variable called top-up sig, and then await elusive.send elusive transaction, and then pass in top-up TX. So now all we need to do is actually build the private transaction itself and push it to the network. Let's go ahead and do that in a variable called sendTX and set that equal to await elusive.build sendTX. And then in here, very similar to the top-up transaction, we can just define our amount. This will be 0.01 and then multiplied by LAN ports per sol. We'll also need to pass in our recipient. And then finally, again, because we're defining the value in LAN ports, we can just pass in LAN ports. For standard send transactions, you actually don't even need to sign it, as Elusiv leverages zero-knowledge proofs to prove ownership of private funds. So that means that all there's left to do is push the transaction to the network. We can do this in a variable called sendSig and set that equal to await elusive.send elusivtx and just simply pass in our sendtx variable. At this point, we've defined all of our base libraries, defined our two accounts, generated an input seed, created our Elusiv instance, built and pushed the private balance top-up transaction, and then additionally, we built and pushed the private transaction itself. So then all we have to do now is print out the signatures. Now we can just go ahead and run it and see if it works. And it looks like it worked. We have the top-up signature here, as well as the send signature here. So let's go ahead and copy the send signature and take a look at it on an Explorer. So this is the transaction that we just sent. This transaction is private and encrypted. This was episode 17 of Chainstack's Byte-Size BUIDLing series. If you'd like to watch the other 16 episodes just like this one, then you can take a look at the playlist linked below. Additionally, within this video, I launched a Solana DevNet node on Chainstack. If you'd like to use Chainstack for your own Solana project, or just learn more about Chainstack Elastic nodes, then you can do so through the link below.